our literature short course, we are talking about how to calculate the carrying capacity of pipe foundation. Before I start the problem, I'll just review the equation because we're going to use the same equation for all the problems. So I will go fast through it, and then I'll show you the numbers at the end. So I will not solve it like step by step because what I'm going to do, you have the equation, you apply the number in the equation, but I'll give you the final answer for each part, and we'll discuss it with us. Because that's the important part, how to understand the numbers. Is it a correct number or a wrong number? Why it's bigger? Why it's smaller? What's the difference? That's the important part. Not the like applying numbers in the equation is not the important part for now. Maybe for undergraduate, yes, that's the main purpose of the class. So, in order to calculate the ultimate carrying capacity of a single pipe, we have the single pipe capacity come from two parts: Q bearing and Q friction. Bearing is the bearing load at the pipe tip at the bottom here, and frictions on the side. For the Q bearing, we calculated C and C, or Q naught and Q. It's the same equation used in foundation, but we neglect the third part, which is half B gamma and gamma, because it's very small, because the pipe tip is very small compared to the heads. Okay? So it's like this. The first part is for clay soil. If you have C, so you use C and C. For sure, if you don't have sand, so phi is 0 and NQ is 0, so we don't have this term. And the opposite. If you have sand soil, so without telling you C is 0, okay? And this term we don't have. Okay? Because we know for sand we have only phi, we don't have C. Then that's the stress, that's the bearing stress at the bottom here. In order to convert it to force, you have to multiply it by the area. And the area now will be the cross-section area of the pipe at the pipe tip, which is pi squared over 4 if it's circular, or b squared if it is square section. And we can calculate the bearing load. For the friction load, it's a little bit different. Friction, we have two types of friction. We have again friction in clay. C represent is the cohesion of the clay and represent the friction or the cohesion between clay parts. But now we are going to have friction here between the clay material and the pipe material. So there is a new parameter which is adhesion, or it will be a function of C, part of C. If we have cohesion between clay and clay, it's C, but between clay and a different material, it's alpha C. And for sure, this alpha will depend on the type of material or the material of the pipe. So if it is concrete, so I will expect a higher value of phi. If it is steel, because steel is a little bit smooth, so this value of alpha will be a little bit less. Okay? And I think in the lecture there is that like the coefficient of alpha is given according to the pipe material. For the sand, for sand soil, the friction is the same friction equation that's used in any application of soil mechanics, which is any friction is the force multiplied by friction coefficient. The force here, because the friction is in the vertical direction, so the force should be horizontal force. And we are dealing with stresses in soil, so instead of dealing with forces, will be the friction stress in the vertical direction. So I need the horizontal, the perpendicular stresses. The horizontal stresses, to calculate the horizontal stresses in the soil, it looks like earth pressure, but it's not the exact theory of active and passive, because here, pile, it depends on the pile installation. So if you have a driven pile, you push the soil aside, so it's a kind of passive. Or if you have a poured pile, so you remove the soil from the pile area, okay, so the soil might move a little bit toward the pile, so we have an active. The pile will not be, the minimum will be the active and the maximum will be the passive, but the actual value will be something in between. Okay? So in order to find the horizontal stresses, and you know that the earth's pressure is a function of the load. So you got the load multiplied by horizontal coefficient, you change it to horizontal stress. And that's what we have here. We have this, the vertical stresses. How to calculate the vertical stresses in soil? I think that's the basic. It's gamma H. But you should think about when you see gamma, whatever you see, whenever you see gamma in soil, you have to think which unit weight you're going to use. Dry or saturated or submerged. For sure, above the ground water table, it will be dry or saturated based on the soil, or under the water we should use gamma submersion. And then multiplied by the thickness or the height of the soil. Then K is the horizontal coefficient, most probably will be given, or you can estimate it according to, as I said, it depends on the pile installation, if it is driven or poured pile. Okay? And also it depends on the size of the pile, if it is a small pile or a big pile. Because when you have a bigger pile diameter, so you're going to push the soil more, so you're going to have more coefficient. Okay? Then multiplied by the coefficient, the friction coefficient, which is tan. Usually you know it as tan phi. You know that the friction stress tau equals C plus sigma tan phi. But again, the same reason why we use alpha is the answer for delta. Why we don't use phi, we use delta. Because phi is the friction angle between sand and sand soil, between inside the sand soil. But now we have friction between the pile material and the sand soil. That's why we have to reduce phi a little bit, and we have delta. And again, delta depends on the pile material, the same as alpha. So if you have a smooth pile, steel or something like this delta will be smaller than phi, or much smaller than phi, but if you have concrete, it will be almost as phi. Okay? So in order here, what we don't know is NC is always constant as 9. Okay, so if you open any textbook, it's even if it change, it will change between 8 to 10, so it's always 9. And then NQ is a function of phi, and according to this chart here, based on the phi, you can go up and find NQ very simple. Also alpha, there is a relation between the C of the soil and alpha. Okay, so based on the C value, you can go up here, head this curve, go down, go horizontal, so you can find alpha. And if you see here, alpha changed from 1 to 0. For sure it will not be 0, but that's it. Okay? Any question for this part? For the pile group, we don't put single pile. We usually we use multiple piles to support the structure, or to support the core. The capacity of the group sometimes is different than the capacity of the single pile. So for the capacity of the group, you have to check on 2 parts. The first part, which is logic, you calculate the capacity of a single pile and you multiply by the number of the piles. So if you have 9 piles supporting a column, so the capacity of this group will be the capacity of a single pile multiplied by 9. But in some cases, when you have the pile closer to each other, okay, we're going to have something called block failure. So the whole group acts as just one pile, one big pile. So we have to check on this case in a separate calculations. How to calculate the capacity of the group according to the block failure? For the block failure, we will assume the pile or the group as just one pile, one rectangular pile. And the width of the pile will be calculated using this equation. This equation is not constant. Again, it depends on how many piles you have. So if you have 3 by 3, it will be different. So here, for example, in this example, we are going to assume that we have a rectangular pile, one big rectangular pile with this dimension, and recalculate the capacity of this single pile as Q bearing. Okay, but the bearing area now will not be the small area, will be the big area. And the friction will not be the friction area along the side of one pile. No, will be the friction area of the whole rectangle. The only change between the single and block failure is this. Do you remember what we changed here? For the single, yes, for the single there was alpha because it's friction between pile and soil. Now this pile, most of it, or most of the surface is soil. So here, that's friction between soil, and here is soil, and here is soil, and here is soil. So most of it is between soil and soil. That's why we don't need alpha anymore. So we can use just C, and the same for phi, we can use phi if it is in sand soil. Which one you're gonna choose? If this Q group of this calculation give you 2,000 and this give you 1,500, so which one you're gonna choose? The critical one, which is the smaller value. Okay? What's the best design if you have to? If you want to change, what's the best design? If you have 2 numbers and they said, okay, you can change some parameters here, you can change L, you can change the spacing. What's the best options.
Change
Change the spacing. The spacing. To change the spacing, what gonna change? The spacing will affect this value? No, because that's the maximum capacity. But when you increase the spacing, you're gonna increase this value. Okay, and the best design is to have them equal. You know, because if this capacity is bigger than this, it means you have a bigger space. Okay, if the capacity of the group is less than this, so it means you have a very small spacing, so you lose more the capacity of the single pipe. So it's the best design is to have them equal. And the efficiency of the group could be calculated based the Q ultimate of the clock failure, the Q ultimate calculated from this, divided by the Q single multiplied by the number of the parts. Okay? In equation, this part is very important. Yes?
For gamma, let's be, why does it have a subscript of 3?
Where is gamma?
For the gamma.
This?
Yeah.
Sigma?
For sigma.
Sigma. That's sigma V center line. Why sigma V center line? Here, what's the vertical stress at that point? I said here sigma is the vertical stress, yes? The vertical stress here is 0. And at the end of the time, it's gamma L.
Yeah, so
Which one you're going to take? Usually you take the average of the layer. That's why I wrote it sigma center line. So that's the stress at the center line of the part or of the layer. Exactly. Sure, that you're gonna reduce this value a lot. No, because it depends on the application that you are using. It depends on many parameters. So you have to test it. Sometimes they do like they put steel. They do it in a sheet box. Instead of having all the box filled with sand, they put the steel material or the pipe material, and they put the type of lubrication that they're gonna use, and then they put sand on top, and they do a shear test, and from the shear test results, that will be your data. That's how they find it in the laptop. There's no track. Okay? So the single and pipe capacity is clear now. Any question? Okay. Again here, what's Q node?
stress at the end of the pipe.
Exactly. Q node is the overburden stress. It's gamma H, summation of gamma H from the ground level up to the pipe tip. So always remember there is two overburden stresses. For Q node, it's for the bearing load, so at the pipe tip. But for the friction, it's at the center line of each layer. Don't make mistake.
Of each layer?
Yes, because for sure if you have different value of phi, okay, so this layer will create a certain friction, and the second layer will create a different friction. So we have to calculate each layer separately. The friction of each layer will be calculated separately. That's why always you will see gamma friction is like summation, because maybe you have different layers. Why we don't calculate different Q bearing for each layer also?
Because it's just at the end of the...
Exactly, because the bearing only appear in the last layer. So we don't have bearing in each layer. So we have just one bearing, but maybe different values for
friction.
the friction. We have two important, yes?
And what for gamma calculating bearing capacity at the end of the pit? If we have 3 layers, we have to consider 3 different gamma.
Yes?
And
Okay? So 3 different gamma. So the friction for friction or for bearing?
for bearing capacity.
For bearing capacity is friction and bearing load. Which part?
Bearing.
Which part? Q bearing?
Q bearing.
Q bearing. So Q node will be gamma 1 H1 plus gamma 2 H2 plus gamma 3 H3. Okay? We have 2 important critical cases.